equations. So far we've learned solve by graphing. Today we're going to move on to solve by substitution. Graphing isn't always the best way in case something doesn't work out evenly. Substitution is a second option. So, solve by substitution, just to recall what the word substitution means, we learned in middle school if x equals 9 and you want to find x plus 4, you substitute the 9 in place of the x. So 9 plus 4 equals 13. So that is substitution in general. You're plugging a number or something in to replace something else. So when we have a systems of equations, remember systems have two letters and two variables, or two equations. Choose to get a letter by itself, either x equals or y equals. So since we're not graphing, you don't have to put it in y equals. If x equals is easier to get by itself, then that's what we want to do. So, if you look at this equation here, we have y equals. So this whole thing right here is what we're going to replace the y with. Substitute the expression into the other equation for that variable. So if this is y equals, we're going to replace this y here with that whole thing. Remember, if this y has no number in front of it, it's considered a 1y. So when I write this down, I would say 3x plus 1 times 2x plus 1 equals negative 9. So the only thing I replaced in this bottom equation was where the y equals, I put in what y equals. Then if you distribute, you get 3x plus 2x plus 1. That's 2 times 1, 1 times 1. Will become binary like terms. This is just our solving. Once you substitute in, we're just using all the solving we learned from Unit 1. So you would subtract 1 to the other side here. 5x equals negative 10. Okay, negative 9 minus 1 is negative 10, and then you would be dividing by 5 to get x by itself. So negative 10 divided by 5 is negative 2. Okay, so step 1, we had a letter by itself. This one happened to be y equals. Step 2, I substituted that expression into the other equation. Step 3, I've now solved for that variable. I got x equals negative 2. So we're ready for step 4. Then use that answer to plug back into your x equals or y equals problem. Technically, you can plug this answer back into any equation that we have up here. But if you have the problem y equals 2x plus 1, and we want to plug in x equals negative 2. So 2 times negative 2 is negative 4 plus 1 equals negative 3. So the ordered pair, remember we always write our ordered pairs as x comma y. So this ordered pair would be negative 2, negative 3. So if we wanted to graph these two equations like we did last class, you could graph each of them and figure out that they meet at that point. If you don't have graphs, this is another way to do it. So you get x or y by itself, either one. You substitute into the other equation. Your answer should be an ordered pair x, y. If using different letters, they write it alphabetically. Like if they have A and B, you put A first, then B. Alright, question 2 here. They give us the answer, or they give us x equals 6 minus 2y. So wherever you see a x, we're going to plug that whole thing in. So here's my x. We're going to replace the x, because this is x equals, with this. So that whole thing is going to go in there. So 3 parentheses, we'll put this whole thing in there. That's called an expression. And then copy down the rest of the problem. That's called substitution. We replace something with something else. Once you've substituted in, the next step is to distribute. Then bring down minus 4y equals 28. So substitute, distribute. Now we're going to combine like terms. So we have a negative 6y minus 4y. That gives me minus 10y. So that was our combining like terms. Okay, then we're going to solve, so we'll subtract 18 to the other side. You're left with negative 10y equals 10 when you subtract that. And then we'll divide by negative 10. Okay, once you have one answer, you substitute it back into your problem. So we have the problem x equals 6 minus 2y. So we're going to replace the y with negative 1. 2 times negative 1. So negative 2 times negative 1 gives me positive 2. So x equals 8. And when you write your ordered pair, your answer, or they sometimes call it the solution, I think there's a blank on the homework that's like solution blank. So this solution would be 8, negative 1, because the x goes first and then your y answer. Alright, the next one is a little bit more tricky. It doesn't say x equals or y equals. So you look at the problem and you try to decide, okay, what letter looks the easiest to get by itself? When I mean easiest, I mean I don't have any fractions or decimals. So if it's possible, I always try and pick the letter that doesn't have a number by it. So like that letter y doesn't have any number in front of it. So that to me would be the easiest one to get by itself. So the opposite here would be to add 2x to the other side. So you get y equals 2x plus 12. Now you're ready to substitute this whole thing. This is just like the last one. Now instead of x equals, we have y equals this. That did not work out well. And you're going to replace it in the other equation. So since I used the bottom equation this time, I have to substitute that into the top equation. So I'm going to circle there the y, and we're going to replace wherever the y is with this whole thing. So you get a letter by itself, substitute it into the other equation. Now we're ready to solve. We start solving with distributing. Distribute means multiply the 3 to both of these. Now after you distribute, you combine your like terms. 5x plus 6x is 11x. Then we will subtract the 36 to the other side, because we're solving here. I get 11x equals negative 33, and then you would divide both sides by 11, so x equals negative 3. Remember, we're not done. We have to plug it back in somewhere to find the other answer. So I would plug it into my y equals one. Y equals 2x plus 12. So we know x is negative 3. So 2 times negative 3 plus 12. Again, we're substituting our answer we got back into an equation over here. 2 times negative 3 is negative 6. When you add those together, negative 6 plus 12 is positive 6. So the solution, what you would write on your line for solution would be negative 3, 6. That is the solution. That is where if we were to graph these two lines on the coordinate plane, they would meet, or they would intersect at the point negative 3, 6. So all of those we've had so far have one solution. We found x, we found y, and then we wrote our answer as an ordered pair. That's considered the solution. That's where the two lines meet at. Okay, I say that because here's an example of what we did last class. We talked about, okay, if you graph it and they meet at a point, that is called the solution. So in this case, they met at one point, so they have one solution. This one, parallel lines never meet, so they have no solution. And this one, when they have infinitely the same number of points, every point exactly the same, the two lines overlap, that's infinite solution. You can tell by these problems they look the same as the other ones. So we're going to solve by substitution. Since that's what we're doing today. So this top equation here is in the form y equals. So we're going to replace the y value with what y equals. I'll copy down the problem, but I'll take out the y because we're going to replace the y with 2x minus 4. So it's substitution, replacing the variable with something else. Now we're solving. To solve, you distribute to get rid of parentheses. Distribute means multiply that to each number inside the parentheses. Oh, sorry. 4 times 3 is 12. It's really bad. Maybe I should just write it. Make that look more like a 12. A little bit more like a 12 now. 3 times 2 was 6, 3 times 4 was 12. Okay, and then bring down negative 12. If after you distribute, you combine your like terms, if you notice here, negative 6x and 6x, there's no x's left. They just cancel each other out. So you're left with negative 12 equals negative 12. Well, that's a true statement. Those two things are equal, but there's no x's to solve for. So that means this is infinite solutions. Infinite solutions is when there's no variables left and the numbers are equal. So like I said, 6x minus 6x, there's no x's. But the numbers negative 12 and negative 12 are equal, so that's called infinite solutions. It means every point, every value you plug in for x would work on this one. Question B, we have to decide if we want to get x by itself, y by itself. It doesn't matter. You could use the top equation to get y by itself. You would just need to add y to the other side and subtract 5. This one's almost y by itself. The only thing we would have to do would be to divide to get rid of that number. So I'm going to do that, I think. I'll divide these all by 4. So 8 divided by 4 gives me 2x. 12 divided by 4 gives me 3. Okay? So now I'm going to take that and I'm going to substitute it in up here where the y equals, or the y is, because I have y equals. Remember, if there's not a number in front of this minus y, that's minus 1y. Okay? So minus 1 times 2x plus 3 equals 5. So get a letter by itself. Substitute it in. After you substitute it in, you distribute. Negative 1 times 2x is negative 2x. Negative 1 times 3 is negative 3. You'll notice on this one too, 2x minus 2x, when you go to combine your like terms, these cancel each other out. So you're left with negative 3 equals 5. Since those things are not equal, this is called no solution. You don't have to go any further. No solution happens when no variables left. There's no variables left, and the numbers are not equal. So infinite solutions are when you have no variables left, but the numbers are equal, like negative 12 equals negative 12. No solution is when you have no variables left in the problem, but the numbers you have at the end are not equal. So negative 3 doesn't equal 5, so this is no solution. There's no number that will work in there. And remember what that would look like graphically are these things. This is an example, no solution, they never meet. This is infinite solutions, all numbers work. So the problems are kind of mixed together. They all start off looking the same. You don't know if it's going to be one solution, no solution, or infinite solution. So you just have to get x or y by itself. Here we chose y, some of the other ones we chose x, and substitute into your other equation. On both of these examples, on this example I substituted into the second one, on this one I substituted into the first one. So there's not a right or wrong way which one you have to substitute into. You just need to have a variable by itself, like y equals, to substitute in, okay?